Hi, this video is part of a series of videos on student misconceptions regarding ratios and proportions. In this video, we will talk about prevalent student misconceptions in the concept of inverse proportionality. Let us take a sample question. In this question, it is given that 3 farmers can reap a field in 6 hours. The owner wants the field to be reaped in 1 hour. How many farmers should he have working on the field in all? Options are A. 1 by 6, B. 1 by 2, C. 9 and D. 18. The data shows us that out of 5,040 students of grade 9 who attempted this question, only about 50% answered it correctly by recognizing that this is a case of inverse variation and that as the time taken to reap the field decreases, the number of people needed to do the job will increase. We must note that around 19% students are applying direct proportionality to this question and coming up with the answer is B, while some others are simply adding the values of the first statement. This reflects not only a clear lack of understanding of inverse proportionality, but also the simple logic behind it. Let us see another question. In this question, it is stated that in a factory, a machine can put lids on 10 bottles in 1 minute. After the new machine oil is used, the time taken to put the same number of lids is halved. On how many bottles can the machine put lids in 1 minute now? The options are A. 20, B. 15 and C. 5. The data on this question shows us that out of a total of 3,513 students of grade 8 who attempted this question, only about 60% chose the correct answer, which was option A, while around 26% chose option C, which once again shows us that they are applying direct proportionality to questions where logically we should be using inverse proportionality. Many students also simply see the value 10 and the term halved and then blindly choose option C by concluding that it should be 5. Let us try and figure out some causes behind this misconception. First and foremost is the lack of understanding of what inverse variation is. Students do not recognize cases where inverse variation is used and therefore confuse it with direct proportionality. Most students are habituated with the use of direct proportions and unitary method to solve problems since they use them extensively in earlier classes. They also use unitary method often to solve word problems, so they sometimes incorrectly use it in these cases. One reason for the lack of a deep understanding of inverse proportionality might also be the very formulaic and non-contextual way in which inverse proportionality is sometimes taught to students. So according to research on this concept, some remediation methods are firstly to introduce the concept that objects are not always in direct proportion. We can show cases where one object decreases while the other increases. For example, if we are pushing a car with all our strength, the lesser the weight of the car, the greater the acceleration we can create. Or the greater the speed of running, the less time it takes to get somewhere. Also, to introduce the concept of inverse variation, we can give simple time work problems, such as 4 carpenters take 3 days to build a table. If 2 of them leave, would it take the remaining carpenters more time or less time to make the table? Once students grasp this simple concept, we can then move to more advanced problems, such as whether the time taken would be half the time it would initially have taken, and so on. We can also use ratio tables to clearly and visually explain inverse proportionality to students. This is useful in both time work as well as speed and time questions. For example, in a question like this, where the speed of a bus, a car and a motorbike and the time taken by each to travel from Delhi to Corbett are given to the student. We have made 2 rows for speed and time and filled columns with respective values of the modes of transportation. Then we have asked students to deduce how much time would be taken by a train to travel the same distance when the speed is given. Here the student can clearly deduce that the products of the terms of the 2 rows are always constant, which is the basic concept behind inverse proportionality. From this, the students can also deduce the time taken by the train as well as the total distance. So, in this video, we talked about some prevalent misconceptions among students regarding inverse proportionality and some ways for teachers to tackle these problems effectively in the classroom. I hope you found this video useful and informative. Thanks for watching.